Aging is something every human experiences, but for the first time in history, science has developed tools that can measure how fast our bodies are actually aging on the inside. These tools, known as biological aging tests or aging clocks, are changing the way doctors and researchers think about age, health, disease, and longevity. For decades, people believed that aging was simply about the number of birthdays one had celebrated. Your chronological age, the number of years you've lived, was considered the most reliable indicator of how old you actually were. But in recent years, a surprising discovery has shaken the foundations of modern medicine. Your chronological age often has very little to do with how old your organs, cells, and internal systems truly are. Inside your body, every organ and every cell ages at its own pace. Two people who are both 40 years old may have completely different biological ages. One might have the heart of a typical 30-year-old, while the other could have the biological signs of a 55-year-old. This difference explains why some people stay active and healthy into their 80s, while others begin experiencing chronic illness as early as their 40s. The emergence of aging clocks aims to reveal this hidden reality by measuring internal aging with scientific precision. Biological aging clocks work by analyzing patterns inside the body that correlate with aging. These patterns can come from DNA, blood markers, proteins, metabolism, immune responses, and even tiny chemical changes on the surface of genes. Scientists have discovered that aging leaves fingerprints inside the body, and by reading those fingerprints, aging clocks can estimate how old your body truly is. If the clock says you're biologically older than your chronological age, it means your body is aging faster than normal and you're at a higher risk of age-related diseases like heart disease, diabetes, dementia, and even early mortality. If the clock says you're biologically older than your chronological age, it means your body is aging faster than normal and you're at a higher risk of age-related diseases like heart disease, diabetes, dementia, and even early mortality. If the clock says you're biologically younger, it means your lifestyle, genes, and habits are slowing down aging. The earliest and most popular type of aging clock is based on DNA methylation. This process refers to tiny chemical marks called methyl groups that attach to DNA as we age. These marks do not change the genetic code but influence how genes behave. Scientists discovered that by examining thousands of these methylation marks across the genome, they could predict a person's biological age with impressive accuracy. These tests were named epigenetic clocks. The first generation of these clocks proved that biological age was not just a theory. It could be measured. Over time, newer generations of clocks emerged with better accuracy, stronger disease prediction abilities, and more detailed insights into how organs and systems age differently. As research advanced, scientists realized that blood carries important clues about aging as well. Proteins, inflammatory markers, glucose levels, metabolic byproducts, immune signals, and hormonal changes all reveal the speed at which the body is deteriorating or staying healthy. Proteomic clocks, which analyze hundreds of proteins in the blood, became the second major generation of aging clocks. These clocks can predict the risk of heart attacks, stroke, diabetes, and even cognitive decline years before symptoms appear. They show how interconnected aging and chronic disease truly are. Biological age is essentially a measurement of how much damage the body has accumulated over time. More advanced aging clocks now combine DNA changes, blood markers, metabolic rates, cellular health data, and machine learning algorithms to offer even more accurate predictions. These systems examine how fast a person's cells divide, how well mitochondria are functioning, how quickly the immune system responds, and how much cellular waste the body is accumulating. They also consider lifestyle habits like sleep, diet, stress, and physical activity. The latest clocks are even capable of predicting how well someone is likely to respond to anti-aging interventions such as exercise, fasting, supplements, or medication. Despite these advancements, aging clocks are not flawless. They can estimate risk, but they cannot perfectly predict the future. Scientists agree that biological age is more dynamic than chronological age. A person who changes their lifestyle, improves their diet, reduces stress, begins exercising, or sleeps better can potentially reverse their biological age. Research has shown that biological age can fluctuate by several years in just a matter of months based on lifestyle changes, illness, or recovery. For example, People who suffer from temporary severe stress or infection may experience a sudden increase in biological age, which sometimes returns to normal after recovery. One of the biggest reasons aging clocks have gained popularity is because they offer people a chance to understand their health from a new perspective. Instead of waiting for disease to develop, individuals can now detect early warning signs through biological age testing. If the test shows accelerated aging, it can motivate someone to change habits long before disease takes root. Doctors may also use these tests in the future to tailor personalized treatment and prevention plans based on a patient's biological age rather than their birth year. Even though aging clocks are powerful tools, scientists are still cautious. They warn that these clocks are not yet perfect enough for doctors to rely on them as medical diagnostic tools. Some tests are better at predicting certain diseases than others. Some clocks work well in large populations but less accurately in individuals. The science behind biological aging is still evolving, and researchers are continuously discovering new signals that improve accuracy. One important question researchers are exploring is whether reducing biological age actually reduces the risk of disease. Some early studies show promising results. People who lowered their biological age through lifestyle changes often experienced better metabolic health, lower inflammation, improved cardiovascular function, and stronger immune responses. But more long-term research is needed to confirm that improvements in biological age translate into longer, healthier lives. Aging clocks also raise philosophical and emotional questions. If a test reveals that someone is biologically older than expected, it can create anxiety or fear. At the same time, discovering that you are biologically younger can boost confidence and motivate healthier choices. The psychological impact of these tests is something scientists recommend considering before taking them. The ultimate goal of aging science is not immortality but healthier, longer lives. Understanding biological age is a major step toward that goal. By revealing the hidden processes occurring inside our bodies, aging clocks give us a deeper understanding of how lifestyle, environment, and biology interact. They show us that aging is not a fixed destiny but a dynamic process influenced by choices we make daily. Whether someone eats healthy food, avoids smoking, manages stress, stays physically active, or prioritizes sleep will all be reflected in their biological age. In this way, aging clocks empower people to take control of their health. While the technology is still developing, the message from researchers is clear. Biological age is a better reflection of your true health than your chronological age. As the science matures, we may reach a point where aging clocks become an essential tool in extending human health span and preventing chronic diseases before they even begin. Aging clocks remind us that the body has a remarkable ability to heal, adapt, and renew itself. They highlight the possibility that aging, once considered an irreversible process, may be more flexible than we ever imagined. Science is moving toward a future where aging can be slowed, measured, and perhaps even reversed. As these technologies continue to evolve, they hold the promise of transforming our understanding of wellness, longevity, and what it truly means to grow old.